Stop. Before you assume this is just another spring weather update, before you glance at the headline and keep scrolling, you need to understand what is happening right now across the United States. Because on one side of this country, in May, people woke up to 2 feet of snow burying their cars, trees crashing through rooftops and 50,000 homes without power, while on the exact opposite side of the same storm system, millions of people were ducking tornadoes, sheltering from golf ball-sized hail, and watching roads dissolve into rivers before dinner time. One storm. One single atmospheric event stretching from the Gulf Coast to the Rocky Mountains, wearing 2 completely different, completely terrifying faces at the same time. This is not the kind of weather that shows up in May. This is the kind of weather that rewrites the records. And right now, it is happening. Get ready, because the word rare is being used by meteorologists in a very precise, non-dramatic way when they describe what just slammed the Central Rockies. Denver, Colorado just recorded its biggest May snowstorm since 2003. Not since last year. Not since a few winters ago. Since 2003, 23 years ago, the city measured 8 inches of snow at Denver International Airport, with the west side of downtown buried under 8 inches of heavy, wet, concrete-dense snow. Boulder recorded 11 inches. Up in the mountains, the numbers become almost surreal. Estes Park, just outside Rocky Mountain National Park, measured 31 inches of snow. Near Long's Peak, a full 33. 8 inches piled up on the mountain. The storm dumped over 2 feet across the Central Rockies at the exact moment that most of those mountains had long since moved into spring conditions. This event is now the 5th largest May snowstorm in all of Denver's recorded meteorological history. Let that settle in for a moment. Not the 5th largest this decade. The 5th largest ever recorded, since the city began keeping weather data. The largest single May snowstorm in Denver history was in 1950, when more than 10 inches fell in late May. The 1898 storm lasted 5 full days and deposited 15.5 inches. The 1898 storm lasted 5 full days and deposited 15.5 inches. Denver has been keeping records for well over a century, and this storm just wrote itself into the permanent top 5. Stay alert, because the reason this storm is so damaging is not just the snow itself, it is the timing. May snow is not impossible in Denver. About 70% of all May months in the city's history have produced at least some measurable accumulation. But the big accumulating storms, the kind that pile 5 or 6 or more inches onto the streets, are rare. And rare May snowstorms carry a specific kind of destruction that a January blizzard simply does not. In January, the trees are bare. The limbs are empty, skeletal, and aerodynamic. Heavy snow falls through them in piles on the ground. In May, the trees have fully leafed out. Every single branch is covered in thick, green, moisture-absorbing foliage. And when heavy, wet May snow, the densest, heaviest kind of snow that the atmosphere produces, lands on those leaf-loaded branches, the weight becomes catastrophic. Branches bow to the ground. Then they crack. Then entire limbs come crashing down onto rooftops, onto parked cars, onto power lines that were never designed to carry that kind of load. Utility crews across the Denver metro area battled through Wednesday, trying to reach neighborhoods where debris-covered streets had become impassable. More than 50,000 customers lost power across Colorado on Wednesday morning. By Thursday, most had it restored, but the tree damage will take weeks or months to fully clear and repair. Neighborhoods in Lakewood and surrounding suburban communities looked less like a spring snowstorm aftermath, and more like the aftermath of a destructive windstorm, with broken timber and downed lines everywhere. Get ready, because the mechanism that created this storm is not a random quirk of the calendar. A discrete, isolated supercell thunderstorm is the most tornado-capable storm type in the atmosphere. It has its own organized circulation, its own rotating updraft, and nothing around it competing for the available energy. Give a discrete supercell a favorable wind shear profile and rich low-level moisture, and it will produce tornadoes. Once multiple storms merge into a large squall line, the tornado risk shifts but does not disappear. Instead, the dominant threat becomes the line itself, screaming east at speeds approaching 60 miles per hour, generating straight-line wind damage along a corridor hundreds of miles wide. Stay alert, because after Tuesday's threat in the Ark-La-Tex region, the front did not stop. It never does. 8 million people from East Texas through Louisiana, Mississippi, and Alabama were next in line as Wednesday arrived, and the system kept marching east. Wednesday's setup was in some ways more concerning than Tuesday's, because the ingredients assembling across the Deep South were extraordinarily potent. The Gulf moisture pulling northward ahead of the advancing cold front was described by forecasters as high-octane fuel, moisture levels running higher than normal even for May, with atmospheric water vapor content so elevated that every storm forming in that environment was going to be an extraordinarily efficient rainfall producer. Forecasters were tracking a wave of energy dropping out of Canada that was on a direct collision course with that deep tropical moisture plume, and the result of that collision was going to wring enormous amounts of rain out of the atmosphere in a very compressed time frame. Some areas were forecast to receive 1.5 to 3 inches of rain, with the possibility of 4 inches in certain spots. And 4 inches of rainfall in a short period of time turns low-lying roads into rivers by dinner time. Get ready, because the flooding concern on Wednesday was not just about flat, low-lying terrain. The southern Appalachians were specifically identified as a high concern area, and for good reason that goes beyond simple geography. When heavy rain falls on mountain terrain, it does not soak slowly into the ground the way flat terrain rain does. It runs off the slopes and funnels into creeks and streams at alarming speed, concentrating enormous volumes of water into narrow channels that can go from a trickle to a wall of rushing water in minutes. In mountain terrain, it takes approximately half as much rain to cause double the problem compared to flat ground. The same rainfall total that would cause manageable street flooding in Memphis can produce a catastrophic flash flood in a mountain creek valley in Tennessee or Alabama. And across the Tennessee Valley and southern Appalachians on Wednesday, that was exactly the combination bearing down. Heavy rain on top of already saturated terrain, funneling into waterways that had nowhere to put the additional volume. Forecasters issued a slight risk for excessive rainfall specifically targeting those regions, and anyone living in a flood-prone mountain community in that zone needed to be watching the water levels around them closely from the moment the storms began. Stay alert and understand that Wednesday night across the Deep South was not going to be a situation where you could go to sleep once the storms arrived and wake up safely in the morning. The storms were forecast to ramp up during the afternoon and sweep through the Tennessee and lower Mississippi valleys overnight. And overnight, severe weather is genuinely more dangerous than daytime severe weather for reasons that are simple and sobering. During the day, you can see the sky. You can watch the clouds rotating. You can see the color of the atmosphere change. You can feel the wind shift and sense the pressure drop. These visual and physical cues give people time to react, even without a formal warning. At night, all of those cues are gone. A tornado can be on the ground a mile from your house and be completely invisible. The only warning you have is the one that comes through your phone or your weather radio, and the only protection you have is the shelter you identified before you fell asleep. Tornadoes that strike at night kill at higher rates than daytime tornadoes for exactly this reason. People do not wake up. They do not make it to shelter. They are still in bed when the walls come down. Get ready. Because there was also a specific wild card that made Wednesday's Deep South setup particularly dangerous: the possibility of discrete supercells forming ahead of the main squall line. The atmosphere over Mississippi and Alabama on Wednesday had wind shear values pushing 65 knots in the vertical column. That is more than enough to get supercells spinning with organized, persistent rotation. If any isolated storms managed to develop ahead of the main line near Jackson or Birmingham, the tornado threat was going to be genuinely high, not just a background possibility. And isolated supercells near major cities in a high shear environment, developing in the late afternoon and sweeping through populated areas after dark, is exactly the scenario that emergency managers lose sleep over. The cap, the layer of warmer air in the mid-levels of the atmosphere that can prevent storms from firing, was the one uncertain variable that could have held back the worst of it. But if that cap broke over Mississippi before the main line arrived, forecasters knew they were going to have serious problems. Stay alert, because the full picture of this storm, the rare May snow burying the Rockies, the severe weather exploding across the South, the flooding threatening the Appalachians, is not just a remarkable weather event. It is a document of what happens when a highly amplified atmospheric pattern combines with an atmosphere that is running warmer and wetter than historical averages across nearly every relevant variable. The cold air that drove the Rockies' snow all the way down to temperatures below 10 degrees at elevation in May was drawn south by a dramatically amplified upper-level pattern, a deeply dipping trough over the southwest that created what meteorologists call a cutoff low, cut off from the main flow and capable of pulling Arctic air southward at a time of year when Arctic air is not supposed to be anywhere near the central United States. At the same time, the Gulf moisture feeding the southern severe weather was running unusually high, higher than is typical even for May, which is already climatologically one of the most moisture-rich months in the central and southern United States. These two extremes, historic cold and snow on one end, explosive moisture-driven convection on the other, are the signature of a pattern that researchers describe as weather whiplash. The term refers to the increasingly rapid and violent swings between weather extremes that characterize a warming climate. Denver went from a high temperature in the low 70s on Monday to buried under nearly 6 inches of snow by Wednesday morning. That is a swing of more than 50 degrees in the effective surface experience in less than 48 hours. The trees that took the full force of the May snow had been absorbing spring sunshine and growing leaves in temperatures that felt like early summer just days before. And the communities in the Gulf South that were sheltering from tornadoes and flash flooding on Wednesday were dealing with moisture levels that were anomalously high because the Gulf of Mexico itself is running warmer than average, pumping more water vapor into every weather system that draws from it. Get ready, because the compounding nature of this storm, the way its cold side and its warm side are both simultaneously breaking records and threatening lives in completely different ways, is a preview of what a more energized atmosphere delivers with increasing regularity. The 2026 severe weather season has already been violent by any historical standard. The April 17th and 18th outbreak confirmed 32 tornadoes across the Midwest. The Enid, Oklahoma EF4 struck with winds between 170 and 175 miles per hour and triggered a tornado emergency. Arkansas, Texas, Wisconsin, Michigan, Illinois, Indiana all hit hard in the weeks leading up to this rare May storm that is now adding another chapter to one of the most relentless spring severe weather sequences in recent memory. Stay alert and treat the storm with the seriousness that every piece of available evidence says it deserves. If you are in the southern severe weather zone, anywhere from East Texas through Alabama and Tennessee, you need a shelter strategy for after dark that is already in place before the storms arrive. If you're on the I-25 corridor in Colorado or anywhere in the Central Rockies, the snow that is on the ground right now is wet and heavy, and the rapid warming that follows will turn it into an avalanche risk at elevation and a flash flood risk in the valleys below as snowmelt accelerates. And if you're planning to drive through the mountains of Colorado or Wyoming in the immediate aftermath of this storm, treat the roads the way you would treat a mid-January blizzard, not a spring road trip. Because the conditions on those mountain passes do not care what the calendar says. This is the rare May storm. It is here. It is breaking records on both sides at the same time. And it is causing problems across half the country simultaneously. Stay alert, get ready, and do not let the word rare fool you into thinking it means safe. In 2026, rare just means we had not seen it in a while. It does not mean we were not warned.